Okay, good evening student. We should start now. So today we will discuss about week 7 assignment of last semester. Then we will discuss about some concept which are taught in this week. Okay, so this is assignment number 7. We will solve question one by one. So in first question, so first question is yes, yes, हाँ हाँ what you are asking, TGA and DTG, TGA, yeah, TGA. Yeah, this is the thermal analysis. Okay, I will cover this point. Okay, just a minute. Let me. Yeah, just a minute. I have added this point. If you want to, just a minute. Let me go on this slide. So you are asking about TGA, na? TGA means thermal gravimetric analysis. Okay, and what other TG? Okay, DTG. Just a minute. It is differential thermal gravimetric. Okay, so what will happen? Let me draw somewhere. Just a minute. So are you able to see this graph? Okay, so in this TGA curve, okay, this is the means TG analysis. Okay, thermogravimetric analysis. So if it is a DTA curve, differential thermometric DTG curve. Okay, differential temperature differential temperature gravimetric. So what will this graph will be look like that. Okay, so it will give you the means the temperature where heat flow is highest. Okay, so by this way you can find out that which temperature heat flow is means rate of mass degradation is highest. So by this way you can calculate. Okay, so this is the difference between these two techniques. And one more thing I want to add, just a minute. Okay, so actually sir taught about this graph are written as means you can say DTG. Okay, DTG differential thermogravimetric and TG only. Okay, so in TG, so what is different between TG and this thing is, if you are plotting TG, so the graph will be look like that. Okay, so I am just giving that only one time mass loss is there. Okay, but the rate of mass will be like that. Okay, means at this temperature rate of mass loss is highest. Okay, so these two graphs are different. This first graph is called as TG and this graph is called as differential thermogravimetric. Okay, DTG. So I think it is clear now. Okay, understood? So this axis will remain same Okay, suppose it is temperature, but this axis for Tg it will be mass loss. Okay, it will be mass loss, and for dTg it will be rate of you can say temperature change. Okay, rate of temperature change means how temperature is changing, at which means at which temperature it will be degradation will be highest. Okay, so like that you can go. Any other question before starting this question answering? Do you have any other question? Malavasu and Priyanka. Okay. Okay. So first question is match the property of the sample given in column B with the thermal techniques given in column A. Okay. So DTG we have already discussed. It is a differential thermogravimetry. So it will give you about the mass change. Okay, then DTA, so differential thermal analysis, so it will give you about the temperature change. Okay, and last differential scanning calorimetry. So calorimetry, its name says, so it will measure enthalpy. Okay, so we can say the enthalpy. Enthalpy means how much energy is required to suppose it is melting. Okay, suppose your ice is melting. Okay, ice is melting in water. Okay, so it requires some energy, na? It requires some energy. Means if you increasing the temperature, okay, so your system will remain at 0 degree centigrade only when your ice is converting in water. Okay, so you are giving energy continuously, but the energy is consuming to convert ice in water. So it is called as latent energy. Okay, latent heat of what's liquidization. Okay, means ice is converting in liquid. So this is called as a this extra heat you provide, delta H. This is called enthalpy of this conversion. Okay, so similarly, understood? Okay, I think it is clear now. Okay, so or okay, so it is very clear now here that first so DTA it will measure mass, so B is right answer. Just a minute, I think it is creating a problem. Okay, then DTA, so it is different temperature analysis, so it will measure temperature change, C. Okay, and last third DSC it will measure enthalpy. So BCA. Okay, our right answer is BCA. Okay, so B will be right answer of this question. Okay, so it is written here, DTG, differential thermogravimetry, is a type of thermal analysis in which rate of mass of sample upon heating is plotted against temperature. Okay, so rate of mass change will be plotted against temperature. Okay, however, the concept DSC, means differential scanning calorimetry was originally derived from earlier differential thermal analysis. Okay, differential thermal analysis means, which we discussed already, how at differential temperature how your mass is changing. Okay, so we will calculate this thing, but in DSC we are at the place of differential temperature we are taking calorimetry. Okay, so that's why it is different. The basic difference between the two techniques in DTA, measure and difference in temperature, where okay, in DTA we measure difference in temperature, whereas in DSC allow the measure of change in enthalpy. Okay, so I think first question is clear. Any doubt you can ask. No. Yes, yeah. Nowadays very sophisticated instruments are there which measure the temperature change due to reaction. Just a minute. Okay, so acid-base titration means it is not for only for acid-base titration. Okay, very minute change are occur. Suppose in living being, if some enzymatic reaction is there, which called metabolism. Okay, so in metabolism the temperature change is very little. Okay, so how you will measure? Okay, so for this type of condition we generally use the temperature change. Okay, so by temperature change we just measure that which reaction is completed or where is end point and like that. Okay. For means laboratory purpose it is very hard to measure, but for microorganism and microsystem or biological system you can calculate. Okay. Then question number second. In the thermogravimetric analysis of FeS2 in inert and aerobic condition will lead to formation of. So FeS2 it is already covered by sir. Okay, FeS2 can be decomposed in two conditions. Okay, first in presence of oxygen or absence of oxygen. Okay, or in any inert atmosphere. So in presence of oxygen it will make ferric sulfate. Why it is ferric sulfate? Because iron is in +3 state. Okay, so whenever any element in higher oxidation state is called ferric. Okay, suppose it is in Fe+2, then it will call as a ferrous, but now it is ferric. Okay, so it will make Fe2SO4 3. Okay, I think you are able to write this. Okay, how formula is written, because it is Fe+3 and SO4 -2. Okay, so whenever you are write formula it will be cross multiplication, so it will be Fe2, okay, and SO4 3. Okay, like that you can write formula. Okay, so it will made Fe2SO3. Okay, but in absence of oxygen it will make FeS. Okay, so the in inert, so in inert condition it will make FeS, and in aerobic condition it will make ferric sulfate. Okay, so I think A is right answer of this question. Okay, so it is written here clearly, in the thermogravimetric analysis FeS2 in aerobic condition will lead to formation. Aerobic means in presence of oxygen it will make ferric sulfate, and upon further rise temperature it will produce Fe2O3. This will, if you rise temperature continuously, then it will again decompose and make Fe2O3 plus SO3 gas. Okay, so again weight loss will be there. Okay, because here it will be weight gaining. Okay, so from FeS to FeSO3, if you count molecular weight, the weight of ferric sulfate is higher. Okay, so initially it is a weight gain. Okay, this upper arrow showing that it is gaining the weight, but after if you are continuously rising temperature, then again it will lose the weight. And why it will lose the weight? Because it is converting Fe2O3 and SO3. So SO3 will be removed in atmosphere, so only Fe2O3 will remain in crucible, and it will lead to weight loss of sample. Okay. Similarly, in inert condition it will formation of APS. Okay. So second question is clear, I think. Any doubt you can ask. Okay. Question number 3. Among the following, the factor that can affect TGA curve. Okay. TGA curve. Suppose. Sorry. Okay. So mass loss and increase of temperature. Okay. So furnace heating rate. Okay. Heating rate will definitely affect the TGA curve. Why it is so? Means heating rate curve means what? Suppose you are heating at 5 degree centigrade per minute. Okay, means the temperature of your furnace will be increased 5 degree per minute. Suppose you can change it, you can rise it like 10 degree per centigrade, 20 degree per centigrade. Okay, or you can decrease it also. Okay, so what is the effect of this step heating rate? Okay, so means suppose you are holding, suppose you are what we can say, heating rate is low, suppose 5 degree centigrade only. Okay, so sample will have more time to decompose at 5 degree centigrade. Okay, so your TGA curve means TGA curve will be changed. Okay, its shapes will be changed because mass loss will be higher at 5 degree centigrade. Okay, means you can say complete decomposition will be occur. Okay, otherwise what will happen if scanning rate is very high like 20 degree centigrade. Okay, so decomposition which should be happen at 5 degree centigrade, it is not possible and it will be occur at higher degree centigrade. Okay, higher degree temperature. So that's so according to that the structure of TGA curve will be changed. Okay, so obviously furnace heating rate will be affect the TGA curve. Second is particle size. Okay, this is another case. If particles are very small, okay, then it will be decomposed separately and easily. But if it is chunk, okay, then the condition will be different. Okay, because first it will be here first only superficial, the particle which are present on surface will be decomposed, then only heat will be move inside, and so the case is different for powder sample and chunk sample. So obviously particle size will be also affect the TGA curve. Then heat of reaction. Okay, so heat of reaction also affect, just a minute, somebody is writing here. Okay, so heat of reaction also affect. Suppose it is heat of reaction means if something is going on in TGA, okay, so it might be exothermic or endothermic reaction. Okay, in exothermic reaction it will create heat, and endothermic reaction it will absorb heat. Okay, so if extra heat, suppose we are taking example of exothermic, so extra heat is supplied by your sample only. Okay, so what will happen? The temperature of furnace will be increased little bit. Okay, means this temperature is increased by sample only. It is not increased by furnace. It is increased by sample. Okay, so mass loss will be noted at temperature. Suppose it should be x, but it is not at x. It will be x plus x dash. Okay, this x dash temperature is given by exothermic reaction. Okay, so by this way also the structure of your TGA curve will be changed. Okay, so we concluded that option A, which is furnace heating rate, option B, which is particle size, and option C, which is heat of reaction. All these factors will affect TGA curve. Okay, so our option will be A, B, C, or okay. So D is the right answer. Okay, the explanation is also given here that at a given temperature, the degree of decomposition is greater, the slower heating rate. Okay, this point I have already explained. If your heating rate is slow, okay, if your heating rate is slow, then decomposition will be higher. at that particular temperature. Okay, means complete decomposition will be there if it is possible. Okay, then only you will rise temperature and further decomposition will be happen. Okay, but if your heating rate is very high, then incomplete decomposition will be there. Okay, and the temperature which should be happen at x degree centigrade, which will be happen at x plus some value delta x, we can say. Okay, so it will be happen at x delta x. So according to that, mass loss will be also measured at x plus delta x. Okay, by your TGA curve. Okay, so the shape will be also changed according to that. Okay, and thus follow this shape of TG curve can be influenced by heating rate. Okay, so first point is clear now. Then second, the particle size will cause change in diffusion of the evolved gas. Okay, because when decomposition will be occur, some gases will be generated. As we any lecture we have already explained, like CO2, CO, oxygen. Okay, this type of gases will be generated. Okay, so if particles are very small, then these gases can evolve easily. Okay, but if it is particle size is more, then these gases will be accumulated in particle only. Okay, greater will be the extent of decomposition at any given temperature. Okay, so if particle size is smaller, decomposition will be higher. Okay, because or you can understand by surface area also. Okay, more surface area will be available if particle size is smaller. Okay, so more decomposition will be occur. So second point is also clear. Then third, the use of large crystal may result in, okay, it is on second point only. Okay, so the use of large crystal may result in apparent very rapid mass loss during heat. Okay, sometimes very large crystal may occur very rapid mass loss. Why it is so? This may be due to mechanical loss of part of sample by from here, when the accumulated evolved gas within the coarse grain are suddenly released. Okay, so suppose it is a big chunk of your sample and there is some gases which are trapped. Okay, so when you increase the temperature, these gases will be evolved. Okay, okay, and due to evolution of these gases, sudden mass loss will be observed. Okay, so it will also change your TGA curve, and you can say it will give incorrect reading. Okay, so it is also not good for analytical purpose. So your sample should be properly grind and powder. The heat of reaction will affect the heat of reaction. This is the third point. Okay, the heat of reaction will affect the extent of which sample temperature proceeds or succeeds the furnace temperature. Okay, because the main work of furnace is what? It will increase temperature as per our requirement. Okay, as per heating rate provided by us. But if temperature is provided by sample itself, okay, or temperature is taken by sample, then your furnace is increasing temperature, but the program will not correct. Okay, so it will also give incorrect reading if your reaction is providing locally in sample. Okay, so these all 3 points are covered. Then question number 4. In thermogravimetric analysis, dynamic inert atmosphere is used. Okay, dynamic inert atmosphere. Inert atmosphere means what? You are not using oxygen, because oxygen can react with many samples. Okay, and can make oxidize your sample. So suppose we are making inert atmosphere like argon, nitrogen. Okay, so what will happen? Why we are using inert atmosphere? Okay, decrease weight loss. Okay, no, it will not affect weight loss. Okay, then reduce rate of decomposition. No, it is also not correct. Increase weight loss. No, then decrease decomposition temperature. Okay, it might be right. Decrease of decomposition temperature. Okay, yes. So it will decrease decomposition temperature. Okay, when you are providing dynamic inert atmosphere, okay, it will decrease decomposition temperature. If the magnetic property of sample is sensitive toward temperature, then a TGA signal will be generated when a sample is measured in, okay, when TGA sample will be generated, okay, TGA sample will be generated when mass will be changed, okay, generally mass loss, sometimes mass gain is also there, but mostly mass loss only, okay. So when mass loss will be occur, TGA will be generated, okay. So in if the magnetic property sample is sensitive toward temperature, okay, so if it is in inhomogeneous magnetic field, okay, if it is in inhomogeneous magnetic field, then obviously it will generate TGA signal, okay. So this is only answer. I think answer A will be correct. Yes. If the magnetic property of sample are sensitive toward temperature, then TGA will generate sample is measured in inhomogeneous magnetic field, okay. So whenever sample in inhomogeneous magnetic field, it will generate TGA due to mass change, okay. Why? Because magnetic property of sample are sensitive toward temperature change, okay. So when temperature change will be there, okay, magnetic property will be changed, okay, and it will provide TGA. Question number 6. In the second step of TGA curve of Hg2 CR of 4, mass loss is due to sublimation of, okay, it is also explained, okay, why it is happen. It is Hg2 CR of 4, okay. So mass loss will be happen. Okay, first of all, what will happen? See, in this reaction only it is written. It is mercurous oxide sublimation. Mercurous. Okay. So in second step, the decomposition of occur to Hg2 and Cr2. Okay. So this will decompose in these two, Hg2 and Cr. Okay. So what will happen? It will be sublimized. Okay. So now this confusion can be occurred that it is mercurous or mercury. Okay. Sorry. Hg can found in two oxidation state, Hg2 and Hg plus. Okay. So always higher oxidation state is called ic and lower is called os, mercurous. Okay. So here you can say oxygen -2, okay, and here if oxidation state is higher, then it is okay. So suffix will be ic, like mercury, okay, and oxidation state is lower, then it is os, like mercurous, okay. Same in Fe+2 and Fe+3 also, okay. So in Fe+3 it is called ferric and it is called ferrous, like that, okay. So right answer will be, because it is Hg plus here, so right answer will be ferrous oxide, okay, clear. So right answer is mercurous oxide, okay. So due to sublimation of mercurous oxide, your wet loss will be there, okay. Then question number 7, the incorrect, okay, so we have to find incorrect statement among the following, okay. So we will check that statement is correct or not. In case of TGA sample is heated at constant heating rate, okay, means we have to fix our heating rate initially, okay, means x degree centigrade per minute, okay. So this heating rate should be fixed first, okay. So this is correct, okay, this is correct statement. So and we are going to find out, we have to find out incorrect statement. So for this case, it is not our option. In case of TGA curve, Mass of sample is plotted against temperature or time. Yes, it is also correct, because mass loss and temperature or time. So it is also correct statement. So it is not right option. Then TGA is used in the analysis of polymer. So polymer, yeah, TGA is mainly used in polymer. Okay, means TGA mainly used, means it is prime analytical techniques for polymer. Okay, so it is also not correct statement. So none of, only this is D is the right answer for this question. Any doubt regarding this question? No? Okay. You can ask question if you have any doubt. Okay. So explanation is thermogravimetric analysis, TGA, is a method of thermal analysis in which mass of sample is measured as function of time and temperature. We have already discussed. In case of TGA, sample is heated at constant heating rate. Okay, it need to fix first. Then TGA is used in the analysis of polymer. Polymer usually melt before they decompose. Thus, TGA is mainly used to investigate thermal stability of polymer. Most of polymer, whatever. Okay, so what polymer, by use of TGA, we can find out glass transition temperature, okay, melting, and glass transition temperature, melting, and crystallization. Okay, so these are the three major three major property of polymer we can characterize by TGA, which are glass transition, melting, and crystallization. For crystallization, we measure DSC. Okay, but it is also techniques. This is a higher version, you can say, over TGA and like that. Okay. So question number 8. In case of TGA analysis, mass loss in the particular temperature range occur due to loss of water of crystallization, decomposition of sample due to unstable and volatile compound, chemical transformation followed by sublimation. Okay, so I think this all options are correct. In case of TGA, mass loss in the particular temperature range occur due to, yes, this all options are correct. So D will be right answer. Okay, so the weight loss of TGA measurement is due to formation of volatile compound produced in your sample. It depends on molecular structure of the compound, that how many decompose it can also. Okay, so it is simple, means simply you can say TG, for understand TG, you can say, suppose you have one tissue paper. Okay, you can say weighted tissue paper. You have one weighted tissue paper which contain moisture. If you are putting in furnace, okay, if you are putting in furnace, what will happen? First, water will be removed. Okay, so first step, water will be removed. Now I am plotting mass loss versus temperature. Okay, initially it is, suppose it is 1 gram here. Okay, so initially water will be removed like that. Okay, just a minute. Okay, I am running only this filter paper, simple filter paper. Okay, so like that mass will be water will be removed. After that, what will happen? Because this filter paper is made by some fibers like cellulose and whatever. So these are made by hydrocarbon only. Okay, CH and some oxygen also. So when it will decompose due to energy, it will make what? CO2 plus H2O. Okay, so like that, when this CO2 and H2O will be formed, it will be vaporized. Okay, and it will lose weight. So after that it will lose, and finally it will be around 0. Okay, so this is simple TGA curve. Okay, so these all options you can understand clearly. Okay, so this same concept you can apply for other chemicals, or also means you are it is nothing but you are burning. Suppose you are burning a wooden piece. Okay, suppose you are burning a wooden piece. Okay, what will happen after complete combustion of this wooden piece? You will find only ash. some S. Okay, suppose it is 100 kg. Initially it was 100 kg, then you will get S of I think in gram, suppose in 50 gram only. Okay, so 100 gram, 100 kg to 15 gram S. So you can compare how much mass loss is there. Okay, so why this mass loss is occur? This mass loss is occur due to burning of constituent of this wood. Okay, so similar this same concept is applied for your sample also. Okay, TG is very simple techniques in analytical chemistry. Then question number 9. Cr2O4 is formed during the thermal decomposition of, okay, Cr2O4 is formed, so option A is correct only, okay, because in Ag2Cr4 different reaction is occur which are written here. Okay, so see here, Ag2Cr4 it will make 2Ag and Cr2O4 and 2O2. Okay, so this is the case of this thing. But what will happen in Ag2, we have already discussed about Ag2Cr4. It will make mercurous oxide plus CrO3. Okay, so it will vaporize and whatever we have already discussed. So this will only give Cr2O4. So right option will be Ag2Cr4. Okay, so A is right option for this question. Up to here, any doubt? You can ask. If you will ask, then it will make more interactive. The class will be more interactive. Pala Vasu, Priyanka, any doubt? Okay. Then question number 10. Choose the correct statement or statements from the following regarding TG analysis of Mg2C2O4H2. Okay, so first statement is just a minute. Magnesium oxalate decomposed to MgCO3 in first step of TG analysis. Okay, so first step H2O will be removed, but it will not make MgCO3. Okay, it will make Mg2 magnesium oxalate only. Okay, so it will make magnesium oxalate only. So the first option is incorrect. Then CO2 is not formed in any step of decomposition. No, it will make CO2 also. Okay, it is not sorry, it is not Cr, it is only C. Let me write. Okay, so what will happen? It will make CO2 plus I think it will make CO only. Okay, then it will make magnesium oxide. So in second step, I think CO2 is not formed. So CO2 is formed. So I think this option is also not correct. Magnesium oxide is formed in second step of decomposition. Yes, magnesium oxide will be formed. Then CO is formed in first step of decomposition. So it is also not correct. CO is not formed in first step. Okay. So only S3 is correct. Yes. By this way we can understand. Okay, so this is the reaction in comparison of calcium oxalate. Magnesium oxalate has two decomposition states. Okay, in first decomposition state, water will be removed only. Okay, from 100 to 250 degrees centigrade in this temperature range, water will be removed and you will get dehydrated magnesium oxalate. Okay, dehydrated magnesium oxalate, if you give further heat, then it will convert in magnesium oxide, carbon monoxide and carbon dioxide. Okay, so first option is incorrect because we are getting magnesium oxalate, not magnesium carbonate. Okay, so first option is incorrect, that's why. One option is that CO is formed in first decomposition, so it is also not correct. Then CO2 is not formed in any stage, so it is not correct because CO2 is forming in second step. So finally only one option is correct where magnesium oxide is forming in this reaction. Okay. So this is all about Just a minute, let me somebody getting in. Okay, so this is all about the assignment which given in last semester. Okay, so I have covered all 10 questions. Any doubt in this question you can ask. Yes, yes, somebody raise hand. Yeah, you can ask, you can unmute yourself or you can write in chat box. Goila Devi, you have raised your hand. So please unmute and you can say. No? Okay, so Pala Vasu, you have one doubt na initially, so I have explained all. Yeah, so this is clear or I will explain once more. Ha, yes, yes, yes. Okay, okay. So, yeah, yeah, yeah. Okay, just a minute. So, are you able to see my screen, na? Okay, so first of all we are okay, so I will give you a brief about these techniques, then we will come then we will conclude. Okay, then if you have any doubt you can ask. I will first move fast. Okay, and then yeah, so TGA already we have covered. Okay, it is very simple technique. Okay, so where what we measure mass of sample measure over the time and temperature. This is very simple technique. So this is clear, na? TGA is clear. Yeah, so this is the thermogravimetric analysis. Okay, and you are asking about what differential thermal analysis. DTA is different. If you are thermal gravimetric analysis also. Thermal or thermo is same. Okay, somewhere you will found thermal or somewhere you found thermo. It is same. Okay, okay. Let me know. So just a minute. I am writing all this thing here. First TGA is already written here. Then DTA. Is it clear what is DTA? Differential thermal analysis. Then DSC. Okay. So I will explain one by one. Okay. So TGA is already clear. Differential thermal analysis means what you are measure here means differential thermal. You are taking you are measuring temperature change. Okay, and you are measuring the what say suppose it is temperature change. Okay, temperature change. So how temperature will change will be there. Suppose your sample is there and it is kept in furnace. Okay, so when you provide heat it will decompose. Okay, but where it will be decomposed completely, this should be measured, na? Where it will be decomposed completely, where it will be start decomposing and where it will be decomposed at highest rate. Okay, so that's why we plot DTA curve. Okay, in DTA curve what will delta T means temperature change. Delta T, it is measured by it is already cleared by sir. Ty means T sample. Okay, so what is Ty? Ty is reference. Suppose you are putting one sample which will not change, which will not decompose, okay, in your TGA. So this is the reference sample temperature, and this temperature is your sample. Okay, so how if your sample is decomposing, then temperature will be changed. Yes. Otherwise, how you will measure? Please unmute yourself. So, yeah, yeah. Yes, yes, yeah, yeah. So what will happen? We have to means suppose these are the two slots, okay, and this is the detector. Okay, it is like that. Are you able to Are you able to see D detector? So suppose here you are putting reference R, and here you are putting sample. Okay, so this detector will quantify that how much heat is provided by furnace. Suppose this is the furnace. Okay, so how much heat is provided by furnace, okay, and how much heat is taken by sample. Okay, so means if sample is decomposing, okay, so then how much temperature is changing. So this detector will compare these two things, reference and sample. That's why we need to use reference here. Understood? Detector, it is for heat flow. How much heat how much heat is taken by sample. So how it will be compared? It will be compared with reference only, na? Okay. Suppose you are telling that you run 100 meter. Okay. So the 100 meter is already fixed, no? So how you fix this? So to fix this, we measure reference. Okay. So by this reference we can compare. Okay. Then finally DSC. So DSC means calorimetric, means it will also measure enthalpy. Enthalpy means suppose you are melting something. I have already explained. Suppose you are melting ice to water. So it requires some energy. Okay. Just a minute. Let me explain. In very simple manner we can explain. Okay, just a minute. So this is the temperature, and it is time, and you are melting ice. Okay, suppose 0 degrees here, and you are melting your ice. So what will happen? You will get this type of plot. Are you able to understand what I am drawing here? So here it is ice only, okay, and you are providing temperature. Okay, you are in this system you are providing continuously. You are heating it. Okay, you are continuously heating the system, but from here, suppose it is time 0, and here suppose it is after X second. Suppose it is 50 seconds. Okay, so after 50 seconds also temperature not change from here to here. Why it is so? Because complete ice is not converted in water. So you are providing heat, but this heat energy is consuming in converting ice to water. Okay, so it is called enthalpy of converting ice to water. Okay, it means it is not automatic process. It means ice needs some energy to convert in water. Okay, so you are heating, but this heating is consuming the energy is consuming in converting ice to water. Okay, then temperature will be rise here to here. Then after 100 degree centigrade, so this temperature is 100 degree centigrade. Again, the temperature is fixed. Why it is fixed? Because again energy is consuming in converting liquid to water. Okay, so same thing is same thing is happening here. Okay, so DSC will measure the heat. Okay, means you can say enthalpy of any this type of phenomena. This is means melting and vaporization phenomena. Same thing. There are different type of phenomena like crystallization. Okay, then in polymer I'm telling about the polymer. So there will be some melting, crystallization, glass transition. Okay, so this phenomena also requires some energy. Okay, so DSC can measure the required heat for this system. Okay. D TG. Okay, okay. So TG तो TG is simple ना. TG is means thermogravimetric. It is clear, I think. Okay, mass loss. Okay, I will clear. It is clear na. Mass loss. Then what is DTA? DTG is differential thermogravimetric. Okay, and DTA means differential temperature analysis. Okay, DTG means differential thermal gravimetric, where you will plot. I plot to just let me have some space. Here yes. Okay, this is TGA. Okay, so means mass loss start here. Okay, first mass loss we can say and complete here. But how you will measure that where mass loss is highest? How you can measure? Think little bit, then you will this will be clear. DTG. How you will measure that mass loss will be highest? This is the temperature and it is mass. Can you explain little bit? So mass loss start here. Yeah, by weighing the mass it is okay, but I want to find out the find out the temperature where rate of mass loss is highest. Means mass loss start here and end here, but where highest mass sorry just a minute. Okay, so I want to find out where rate of mass loss is highest. What I am going to find out? Rate of mass loss is highest. Okay, so how you can measure? Means you can say suppose it is 50 degree and it is 100 degree. So by this calculation you can write only one thing, that mass loss start at 50 and end at 100. But if I am asking that where highest mass loss rate was there, then how you will which data you need to plot? If this type of curve is there, then you can identify. Okay, suppose if I am plotting temperature, okay, then I can say at this point highest mass loss is occurring. Understand? Hello? Hello? Are you able to understand or not? So means if you are plotting graph like that, okay, so it is what differential temperature. Okay, so differential temperature means sorry, means I am taking differential temperature. What we can understand that T1, T2, T3, okay, these are the different temperature. Okay, suppose I am taking T1 to T2. Okay, T1 to T2, how much mass loss is there? T2 to T3. This is called as a differential temperature. Okay, so I can say that here at this temperature the mass loss is highest. Okay, here again we can say mass loss. Okay, so mass loss is highest at this temperature. Okay, so by this way you can calculate that where will be the higher, the mass loss rate will be highest at this temperature. Okay, so it will be covered by dTg. Okay, so this is clear. Then three type of, okay, we will discuss little bit about three type of thermogravimetry. Okay, glass transition means where okay, suppose this is the temperature and this is the hardness, you can say. Okay, so suppose this is the polymer, this is the plastic. Okay, so if you are increasing temperature, what will happen? At some temperature it will convert in a rubbery state. Okay, some temperature it will convert in rubbery state. Okay, so it will call glass transition temperature. So viscosity will be changed. Okay, means your plastic will convert in rubbery state. Understood? No? Viscosity you can. Okay, if you are still not able to understand, then I will give you one simple. You know about glass, na? Glass, mirror or glass, anything? Do you? So what is the glass? Do you know about the crystal structure of glass? So the glass, if you see the structure of glass, it is not crystalline. It is the means liquid-like structure. Okay. So glass crystal are liquid-like, means it is flowing liquid. Okay, you can say it is already freeze liquid. Glass is nothing but freeze liquid. So it is not crystalline. Okay. So what will happen when you increase the temperature? The means suppose it is polymer chain. Okay. So what will happen when you increase the temperature? This chain will be start floating one on another. Okay. So it will call glass transition temperature. Means initially it will look like glass, hard. Okay. But when we increase temperature, it will convert in rubbery state. Okay. So this temperature is called as glass transition temperature. Clear? Yeah. Okay, so I will move fast here. These are only this concept already taught by sir, but I will give you only this. If you have any doubt, you can ask me meanwhile. Okay, otherwise I will clear because we have 2-hour class, so I need to cover it. Okay, isothermal or static thermogravimetry. Okay, isothermal means what? We are fixed temperature. Suppose we are putting our temperature furnace not 1000, suppose 800 degree. Okay, we are keeping it fixed. Then we are measuring weight loss. Okay, we earlier we discussed that we are increasing weight like 10 degree centigrade per minute. Okay, so we continuously increasing the temperature in this case, but here in isothermal case we are already fixed our temperature at 800 degree centigrade, and then we are measuring mass loss. Then it is called isothermal or static thermogravity. In this technique, the sample weight is recorded as function of time constant temperature. Second is quasi-static thermogravimetry, means it is quasi means not fully static. So in this technique, the sample is heated constant weight each series of increasing temperature. Like that, what if you plot the temperature with time? Okay, it will be like that. Means you are increasing temperature step by step. Then it will call as a quasi-static thermogravimetry. Then dynamic thermogravimetry, we have already studied about this thing. Okay, it will be like we are increasing temperature in fixed rate. Okay, this rate will be decided by you according to your sample, what you are going to analysis, and what is the time you require, and whatever different factors are there which affect the heating rate. Okay, so these are the three type of then what is the principle of TGA? We have already discussed. Okay, the temperature increase constated for initial weight. Okay, this is already discussed, so I will not. This is the simple TGA curve. Okay, I think it is also clear. Okay, weight loss start here and end here. Okay, so there are two temperatures, Ti and Tf. Okay, so how you can measure? It will be measured in thermobalance. Okay, thermobalance is it is simple only. Okay, it will weight. Suppose it is just a minute. Yeah, we will discuss about thermobalance in next slide. So okay, so there are two curves, Ti and Tf. So what is Ti? Ti is procedural decomposition temperature, where decomposition starts. It is called procedural decomposition temperature, and Tf is final temperature where decomposition is completed. Okay, so the reaction temperature in interval Ti and Tf depend on the experimental condition, therefore they do not have any fixed value. Okay, means it will depend on particle size, particle temperature, heating rate. Okay, so these parameters, if you change the parameter, then Tf and Ti value will be changed. Okay, it is AgNO3 curve. Okay, so when AgNO3 will be decomposed, it will form Ag and NO2 and oxygen. So this gas will be evolved. So obviously mass loss will be occurred. So mass loss will be occurred from here to here. Okay, and it is due to NO2 and oxygen. Okay, so this is all about this type. This is the instrument of TGA. Okay, so in this instrument you can say that this is the furnace. Okay, in furnace this is the sample holder where you will put your sample. Okay, and this is the balance. Okay, means this sample is kept on furnace. Okay, so what will happen when furnace will increase temperature, and how furnace will increase temperature? It will increase temperature by furnace temperature programmer. Okay, it should be in controlled manner. That's why we need one programmer which will increase temperature in constant way. Okay, whatever we need, it will be we have to feed in program. Then it will be heat the then it will be operate the furnace, and it will increase temperature accordingly. Okay, so when temperature will be heat, this sample will be decomposed. Okay, first water will be removed, then some decomposition reaction will be there, and due to this mass change will be there, and this mass change will be recorded by this recording balance, and it will be finally signal will be provided to recorder, and you will find thermogram where you will be able to find out where mass loss will be occur, at which temperature it will be start. Okay, how much time decomposition will be there. Okay, what are the stages, how many stages are there, these things you can interpret by thermograph. Okay, here you can say in instrument of TGA, this sample, this is carrier gas environment. Okay, so suppose you do not want to do TGA in oxygen. Okay, then you need to need a closed chamber where you can provide carrier gas whatever you need, argon, whatever, argon, nitrogen. Okay, inert gas. Then again you can say this this is the balance. So sample is kept on the balance, and it is thermocouple. Okay, which will measure the temperature of the, it is very important. Okay, because you are plotting with temperature, na? So how you will measure temperature? So thermocouple should be there, it will measure the temperature of sample. Okay, so these are the recording balance, sample holder, furnace, temperature programmer, controller, and finally recorder. Okay, so these are the part of your TGA instrument. Okay, recording balance, this is already explained. A microbalance is used to record a change in mass. A ideal microbalance must possess following features. Okay, so what are the features should be in there in your microbalance? It should accurately and reproducible, means your microbalance should be in good quality, because it need to measure very small change in mass. Okay, it need to change, it need to record very small change of mass, so it is very precise. Okay, otherwise your result will not, you will not able to reproduce your result. Okay, and according to atmospheric condition. Okay, because high temperature and high temperature is there, we are going to measure at high temperature, so this balance should be work on higher temperature also. It should provide electronic signal to record. Okay, so whatever mass change recorded by balance, it should be convert this signal to recorder. Okay, so recorder can record this signal, and the electronic signal should provide rapid response to change the mass. Okay, it should be stable in high range, mechanically, electrically. It is operating should be user friendly. What it is very simple thing. Okay, then after the sample has been placed on microbalance, it is left for 10 to 15 minutes to stabilize. Recorder balance are of two types. Okay, so you can recorder balance are two types. First is deflection type instrument and null type instrument. Okay, so it is very simple, I will just cover in just a few minutes. Deflection balance means something is deflecting. Okay, so these are the in beam type. Okay, so it is midpoint. Okay, and this beam is deflecting. Okay, initially it is in horizontal condition, but when mass will be changed, okay, it is deflecting like that. Okay, so you can measure how much change is there. Then helical type, so it is a spring type. Okay, so as mass loss will be there, so spring will be a string. Okay, it will move up. Same, if your sample is gaining mass, it will move down like that. Third is cantilever beam, so this cantilever will be up. Okay, according to weight loss and weight gain. Okay, for weight loss it will be up, and if it will be weight gain, it will move toward down. Then torsional wire, so torsional wire, it is also, this principle are same, only little bit is different, you can understand. Then null balance, it is very advanced technique where it is null detector. Null detector means where when your bar is in a horizontal condition, it will provide null. Okay, but when weight change will be there, okay, whenever weight change will be there, to nullify this effect, it will restore force. Okay, whenever suppose weight is when it will lose weight, so it will try to move up, so it will try to move down. Okay, so to stop to protect to move down this bar, you need to restore some force. Okay, so you can measure this force. Okay, and you can correlate this force with your weight loss. Okay, somebody is waiting here. Okay, so this is the recording balance. sample holder. So sample holder are generally crucible. Okay, so we need to select crucible according to our sample. Okay, its chemical nature and also the working temperature. Okay, decomposition temperature also we should consider. Okay, so according to that there are different type of crucible like platinum, aluminum, quartz. Okay, so sometimes stainless steel, graphite. Okay, so you can use. So it is different, means suppose you are suppose you are going to measure some elements which are reactive toward aluminum. Okay, or alumina or graphite, so you need to use only platinum. Only one option is there. So according to that you need to select your crucible also. And second most example thing is temperature. What is the temperature range you are? Okay, so these are different type of crucible. Okay, they have different type of shape also, like shallow pan, deep crucible, loosely covered crucible and restored crucible. So why we are changing the shape of crucible? For particular use. Okay, suppose you are going to use volatile substance. Okay, so volatile substance you need to use shallow pan, so that the substance can volatile easily. Okay, this is the only purpose behind that. Deep crucible, it is for industrial scale calcination. Okay, so sample will not bump. Okay, because it is deep crucible. Then loosely covered crucible. Okay, self generated atmosphere study. Okay, then you need loosely covered. Self generated atmosphere means sample itself generated atmosphere, then you have to cover. So it is loosely covered. Why we are covering this crucible? Because we need to atmosphere created by sample only. Okay, then it is retort club. It is only used for boiling point study of sample. Okay, so if you are want to see the see the picture of this type of shallow pans, deep crucible. Okay, then loosely covered crucible. Okay, then finally furnace. We have already discussed. Okay, so what is the furnace? Is nothing but a chamber which is made by ceramic, and we provide electric coil like that. Okay, this is the electric coil. Okay, so when you provide electricity, it will be heat up. Suppose nichrome wire. Okay, it is nichrome wire only. So when you will hit this wire, it will provide heat. Okay, so if you are putting some sample here, so it will be also heated up. So this is the working principle of furnace. So it should have a hot zone which can hold sample and crucible and it okay, whatever it is. There are different combination of microbalance and furnace. Okay, so this is the furnace. So this is the sample. So what will you do? Just a minute. So now this sample should be connected with microbalance. Okay, so whatever when and this there one another thing should be there, which is your temperature. Okay, so suppose this is the thermocouple which is measuring temperature. Okay, so by this initially by this electric coil you are heating this your sample. Okay, it will decompose and temperature will be measured by this green color thermocouple, and the mass will be change will be measured by this balance. Okay, so all things is clear. This is means complete you can say complete working principle of your TG. Okay, then temperature programmer controller. Okay, so this is already discussed. You need a controlled rising of temperature. Okay, that's why you need a controller. Okay, thermocouple, we have to measure temperature, we use thermocouple. The position of temperature measuring device related to sample is very important. Okay, how you are providing thermocouple in furnace, how you are providing your thermocouple in furnace is very important. So the major types are how you can place. So it is written here. I just yeah. Okay. So there are three techniques. Where is thermocouple? This is the thermocouple. Okay. So you are putting your thermocouple just below the temperature. Okay. Then another technique is providing thermocouple just at top of the sample, and third, the thermocouple is just touching the sample. Okay. So obviously this technique will provide more accurate result because your thermocouple is touching the sample. So whatever change in the temperature, it will be instantly noticed. Okay. So these techniques will be more accurate compared to A and B. The recorder is okay, it's already covered, nothing is okay. Then what are the factors affecting TGA? What are the factors affecting TGA? So factor affecting the TGA curve, the factor which may affect the TG curve are classified into two main groups: instrumental factor, okay, and sample characterization. Okay, so your TGA curve can be influenced by instrumental factor or sample, means which sample you are going to analyze. Okay, so in instrumental factor we have already discussed, it is furnace heating rate and furnace atmosphere. Furnace atmosphere means presence of oxygen or in inert gas. Okay, so in both cases the TGA will be different. Okay, means how you means correlate this atmosphere with the TGA, because sometimes the oxygen can suppose it is calcium oxide. When it is suppose it is not calcium oxide, suppose you are going to analyze any sample which can react with oxygen. Okay, so it is Fe2O3. Okay, in presence of oxygen and high temperature, it can convert in Fe3O4. I am writing here. Okay, so what happened? Oxygen is added. Okay, so now you are going to analyze Fe2O3, but it is due to presence of oxygen, it is converting in Fe3O3, means gaining of it. Okay, here it is gaining of it. So that's why this type of sample where oxidation is oxidation can be occur. So we generally use inert atmosphere like nitrogen and argon. Okay, so atmosphere is very important for this type of samples. Okay. Then sample characteristics include weight of sample. Okay, weight of sample is very important. Why? Because if you are taking very small weight, okay, so what will happen in TGA? Suppose it is mass loss and it is temperature. Okay, so only very small mass loss will be occur like that. Okay, suppose you are taking very small 1 mg sample like that, but suppose you are taking 10 mg sample, so it will provide little bit more accurate. Okay, so this transition you can analyze more accurately if sample is high, but if sample is very high, then also it will not measure accurately because it will give many steps. Okay, your curve will be like that. Okay, so it will not give accurate result. That's why optimization of sample weight is also very important. Okay, so this factor we will discuss in detail now. First of all, instrumental factor, furnace heating rate. The temperature at which the compound or sample decompose depend upon the heating rate. When the heating rate is high, the decomposition temperature is also high. A heating rate of 3.5 per minute is usually recommended for reliable and reproducible heat. Okay, so 3.5 degree centigrade is recommended. If heating rate is high, okay, suppose you need only Suppose your sample is decomposing at 150 degree centigrade, okay, and it required 5 minutes to decompose completely, okay, at 155 degree. But if your heating rate is very high, okay, suppose it is 100 degree centigrade per minute. For example only, it is not possible generally, but I am just giving you one example. 100 degree centigrade per minute, okay. So means in 1 minute it will change 100 degree, okay. So suppose initially it was 100 and it will be changed in 200 in 1 minute only, okay. It will change 100 to 200 in 1 minute only, but at 150 you need to stay for 5 minutes to complete decomposition, okay. But what will happen, in 1 minute you will rise, means 200, 300, 400, 500, means the temperature will increase very high, okay. So the temperature which can complete at 150 only, you will find weight loss at higher temperature, okay. So what is the consequence of this phenomena is, your decomposition temperature will be higher. You will notice that your decomposition temperature is higher. Your decomposition temperature will be higher, which is not correct. Actually it is 150 only, but you can get higher, it will be 250 or 300, whatever, okay. So this is not accurate way. So the heating rate should be optimized correctly. Second is furnace atmosphere. The atmospheric inside the furnace surrounding the sample has a profound effect on the decomposition temperature on the sample. A pure nitrogen gas from a cylinder passes through the furnace, which provided inert atmosphere, okay. As I already explained, if your sample is active toward oxygen, okay, if it can react with oxygen, if it can oxidize with oxygen, then you need to use inert gas atmosphere. Then sample characterization. So weight of the sample, a small weight of sample is recommended using small weight, okay, small weight but not very small. If it is very small, then you will not able to identify. So it is also depend on sample to sample, okay. Then particle size. So particle size of sample should be small and uniform. The use of large particle crystal may result in apparent very rapid weight loss during heating, okay. So if the particles are very large, so rapid weight loss will be occur. Why it will be so? Because due to removing of gases which is captured by your big sample. Suppose I have already explained this thing also. If it is your chunk of your sample and some gases are there, okay, and if you heat it, then these gases will be removed from sample which are trapped in sample, okay. So if these gases will be removed, suddenly the weight loss will be occur, but it is not occur due to chemical reaction or whatever you are going to study, okay. So it will give wrong result. So other factor affecting TGA curve are sample holder, heat of reaction, compactance of sample, previous history of the sample, okay. So only little bit knowledge is sufficient. Then advantage of TGA, okay. So a relatively small set of data is to be related, okay, means by TGA it is very simple analytic technique, and by only small data you can correlate your sample, you can identify your sample. Continuous recording weight loss as a function of temperature ensure equal weightage to examine over the whole range of study. As a single sample is analyzed over the whole range of temperature, the variation in value of the kinetics parameter, if any, will be indicated. Means kinetic parameter means what? If some phase transition is there, okay, what type of chemical reaction is there, you can measure it also, okay. So there are some reaction, okay, where one phase is changing another phase, okay. So the kinetic of this study you can analyze. Some limitations is also there, okay. TGA means mass change. If mass change is not there in any chemical reaction, then it will be limitation of TGA. Like that, the chemical or physical change which are not accompanied by the change in mass on heating are not indicated in thermodynamic analysis. Okay, so mass change should be there. During TGA, pure fusion reaction, crystallization reaction, glass transition, uh, crystallization of solid state with no volatile substance would not be included. They provide no change in the mass because this parameter do not like glass transition temperature. Okay, so glass transition temperature, what will happen? If you need to plot between and hardness and temperature, but not mass. Okay, so if mass is not changing for any compound, if mass is not changing, then you will not able to identify glass transition temperature by this TGA compound. Similarly, crystallization, okay, and if some volatile compound is not there, then also it will be not applicable. Then final application of TGA. So from TGA we can determine the purity of thermal stability of both primary and secondary standard, determination of composition of complex mixture and decomposition of complex. Okay, whatever you can read it. These are simple things. Okay. So these are the things. Okay, I will discuss some more concepts. Just be here. Okay, so some concepts are left which I need to cover. Meanwhile, if you have any doubt up to here, you can ask. Okay, so one more point is, I think you are able to see my screen. If no, then please tell me. I have shared whiteboard. So if you are not able to see whiteboard, okay, okay, good. Okay, so some points are left. Huh. So titration we already know about titration, but what is thermometric titration? It's very hard to write here. Okay, in thermometric titration, what will happen? Just you can measure. Suppose this is the burette. Okay, and you are adding drop. Suppose this is your sample. Okay, and you are adding base. Okay, at the end point, okay, so if at the end point, if some temperature change, okay, if temperature change at the end point, then this end point can be measured by temperature change only. Okay, so this is the means generally what we do, we generally use some indicator. Okay, so this indicator will change in color, so you can able to identify that now my end point of this reaction is came, but here temperature change will be there, so by temperature change you can measure the end point. Okay, so it is thermometric titration. Then one more point, uh, it is known as Boyle balance. Okay, so what Boyle balance is, it will measure, suppose this is your sample. Okay, and you are putting one magnet here, N and S. Okay, and suppose it is connect with balance, this is the balance. So when suppose it is paramagnetic, okay, suppose it is paramagnetic, then what will happen, this means this magnet will try to attract this. Okay, this magnet will try to attract this sample. Okay, so it will be pulled like that, and in your balance mass gain, okay, mass will be increase of this sample. Okay, mass will be increase, it will show that mass is increasing of this sample, but it is actually due to attraction of paramagnetic to the magnetic field. Okay, so it is due to this Boyle balance can identify paramagnetism by this way. Okay, so weight change delta W can be measured. Okay, and it can be finally it can be measured the paramagnetism of this product. Okay, so now the change side. Okay, it is already covered. Then calcium oxalate, magnesium oxalate we have covered. Okay, remaining all concept I have covered, I think. Sorry. Okay, student. So we have covered all concept. Any doubt up to here? You can ask. Any doubt? Saraswati, sit there. Okay, so you have gone through all video of week 7, huh? I think. No doubt. Okay. Then Miss, you joined late this session about. You are today only, na? Or in the course only you joined late. Okay, today you joined late. So if you want to see the recording, it will be available. Okay, so you can go. It will be shared. It will be because the old recordings are being shared by your course controller, I think. So it will be there. Okay. हाँ हाँ, there are all videos are available. Okay. Okay, then we'll meet in next week. If you are in doubt, you can ask. Otherwise, we will meet in next week. Okay. Okay. हेलो, हाँ सर, फ़ोन किया था आपने? हेलो। हेलो। हाँ, आवाज़ आ रही है? हेलो। 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 हाँ, आवाज़ आ रही है सर? अच्छा, मतलब आपने फ़ोन इसलिए किया ना, सुबह मैंने किया इसलिए। अच्छा अच्छा। हाँ तो मैं वो उस टाइम क्या मुझे वो चाहिए था, डिजिटल वाटर। तो इसलिए मैंने फ़ोन किया था। हाँ हाँ। पहले मैंने आपको किया, फिर नहीं मैंने इसीलिए फ़ोन किया था, मैंने खुला है कि नहीं खुला है। तो फिर वो आरिफ ने फिर मेरे को मिल गया, यहीं से मिल गया, तो फिर मैंने यहीं से ले लिया। हाँ हाँ। अच्छा अच्छा। एक चीज़ मैं कह रहा था कि वो डेसीकेटर मैंने लेके आया हूँ मैं भी, है ना। तो उसमें उसमें सिलिका सिलिके डालते हैं ना कि और कुछ डालते हैं? बस सिलिका जेल ही डालते हैं ना? तो ये तो अपने पास मिल जाएगा ना बहुत सारा, मतलब ये तो पड़ा ही होगा सर के पास अपने उस। अच्छा। और एक मतलब वैक्यूम पंप का और करना है, बाकी वो तो हो गया है। तो वैक्यूम पंप का जाके लाता हूँ। तो फिर सोमवार को एक बार मैं आऊँगा, तो फिर आप उसमें वो एक बार मुझे बता देना कैसे डाल के कैसे क्या करना है। वैसे तो पता है लेकिन फिर भी एक बार, है ना।